Here's a quick video going over some of the concepts about equations and two variables. This is a bit just of an introduction. We're not going over graphing in this video, just the basics. Some vocabulary that we really need to understand if we're going to understand these equations that have two variables instead of one variable is that an equation in two variables is an equation that represents two quantities or numbers that change in relationship to one another. So that means that as one of the variables change, like the x, just to look at the problem down here, as the x changes, the y changes also. So the result is that basically with equations that only have one variable, like x plus 6 equals 7, there's only one answer, x equals 1. That's the only solution. But in equations that have two variables, there wind up being infinite solutions. That doesn't mean that everything is a solution, but since there are two variables, there are a bunch of different things that can be true for those types of equations. So a solution of an equation in two variables is an ordered pair, like these, right? An ordered pair there that makes the equation true. So some ordered pairs might be false in the equation, some ordered pairs might be true in the equation, and it's our job to sort of test it and find out. So let's go ahead and test it out. So identifying solutions, I have two problems here. I'm going to see if they work out to be solutions. So what I'm going to do is I'm going to take the number that represents x, so in an ordered pair, the first number is always the x and the second number is always the y. So I'm going to plug the two numbers in for my x and my y. So instead of y, I'm going to do 21, and instead of x, I'm going to do 3. So 21 equals 5 times 3 plus 6, and I have to see if that works out to be a true statement. So 5 times 3 is 15, and 15 plus 6 equals 21. Yes, it does. So this one turns out to be a solution. So this one is a solution. If you plug in the ordered pair and you wind up with a true statement like this one, then that means that this ordered pair is a solution. So let's try the other one. Y equals 7x minus 9. So instead of y, I'm going to put in 6. This is my y spot. And instead of x, I'm going to put in 2 because 2 is in my x spot. So 7 times 2 minus 9. So 6 equals 14 minus 9. And 14 minus 9 is equal to 5, not 6. So no, that does not work out to be a true statement. So that means that 2, 6, the ordered pair, is not a solution. So we have one that is a solution and one that is not. Okay, next idea here. So every equation in two variables have both an independent and a dependent variable. The variables represent the quantity that can change freely and the other quantity that depends on the one that changes freely. So if you look back at the examples, we had an x and a y. One of them is independent, one of them is dependent. So the variable that represents the quantity that can change freely, that one is called the independent variable. And the other variable is called the dependent variable because its value depends on the independent variable. So up here when I was doing it, number 1 and number 2, it always turned out that my y depended on whatever my x was, right? So if I was just solving these and not checking for solutions and they said x equals 5, then what I would do is I would say like 7 times 5 minus 9, and then I would figure out what the y was when x was 5. So here my x is 5, and I'm figuring out what y is. So x is independent, it gets to change freely. Y is dependent, it depends on whatever x is. Okay, so let's go over an example of that with a word problem. So this is a word problem where I'm going to identify independent and dependent variables, and I'm going to answer the question. So Here we go. The equation y equals 2x plus 8 represents the cost a college student spends on ramen noodles. After initially buying $8 worth, the student then spends $2 per week on ramen noodles. Identify the independent and dependent variables, and how much does the student spend after 1 year? So again, here I have to decide. So my equation was y equals 2x plus 8, and it told me that this x here is the number of weeks that go by because they buy $2 worth of ramen per week. And this is my initial amount of money that the student spent on ramen. And that makes the y here, that makes the y the total. So the question here is, which one changes freely? Is the one that changes freely the total, or is the one that changes freely the weeks? Does the total depend on the number of weeks that went by, or does the weeks depend on the total? Which I think it should be fairly easy to see that it's actually the weeks that determine the total amount of money spent. So here, my independent variable, my independent variable is the x, or the weeks that have gone by. Every week they buy $2 more worth of ramen. And my dependent variable, I just realized I spelled independent wrong. And my dependent variable is the y, or the total cost of ramen. Right, so here, let's spell independent correctly. Okay, I think I spelled dependent wrong too. So my independent variable x, my dependent variable y. Now, the last part that it asks me is, how much does the student spend after 1 year? Well, I know that 1 year is equal to 52 weeks. So I'm just going to use my equation to figure out the total cost after 1 year. So y equals 2 times 52 instead of x, because it's a whole year, plus 8. So 2 times 52 is 104. So after an entire year, the student spends $112 on ramen. So this has been the introduction to solving equations with two variables. If you like the video, like and subscribe, and tune in next time for more math.